Hello everybody, and thank you for attending my presentation. My name is Nick Bartel, and my co-author Dr. Songhee Chon would like to present our study on the relationship between the perception of audio and video resolutions. So, the goal of the study was to examine the perceived quality differences in various audio and video resolutions and their interactions. This resorted to the research questions: will the perceived audio quality be affected by different video resolutions? And inversely, will the perceived video quality be affected by different audio resolutions? With the media industry transitioning further into streaming, we understand the importance of how viewers will perceive the quality of audio and video along with how they interact together. The findings from this study will be relevant to streaming media providers. We formed the basis of our stimuli based on the current practices by these streaming providers. The independent variables included 3 video resolutions and 4 audio resolutions. The video resolutions include low definition 240p video, standard definition 480p video, and Full HD 1080p video. The audio resolutions consisted of 48 kHz and 24-bit audio with AAC bitrate reduction at 16 kilobits, 24 kilobits, 56 kilobits, and 320 kilobits. In total, this study consisted of 12 conditions. The dependent variables included the ratings from 2 separate 5-point Likert scales of the perceived audio and video qualities. Each trial included both scales, as you may see from the picture here, as subjects were asked to rate both the audio and video qualities separately from the same video clips. These clips were 10 seconds long and had 48 unique segments. This means that no videos were repeated. However, each condition was repeated 4 times by 4 different video clips. The 48 clips were grouped into 4 different sets where each condition was only repeated 1 time within the segment. To prevent any internet quality complications, we had subjects download stimuli for this experiment. Subjects accessed this online survey through a Qualtrics link and were asked to download stimuli and play them in full screen mode. In total, the test was about 30 minutes. The entire study was conducted on each subject's own equipment that they would be most likely to stream media on, such as their computer or laptop. The only technical requirement we asked of subjects was to have a minimum of a 1080p viewing screen. If you were wondering earlier, this is why we did not include 4K video resolution, as we could not expect random subjects to own a viewing screen of this resolution. So in total, we had 42 participants complete the study. The subjects were recruited from Belmont University, so it included current and former students from the school. Students were mostly recruited from Mike Curb College of Entertainment and Music Business, so most of them come from a technical background of audio engineering, video production, music business, and motion picture majors. Because of this, we asked subjects to self-identify as being more auditorily or visually inclined. These graphs here represent the quality ratings across all subjects for both audio and video. The graph on the left represents the average perceived video quality ratings, where the y-axis represents the video quality ratings and the x-axis represents the audio resolution. Different video resolutions were specified in separate lines, where you will see 240p is blue, 480p is red, and 1080p is yellow. The error bars indicate standard error. The graph on the right represents the perceived audio quality ratings. This time the y-axis represents the audio quality ratings, and the x-axis represents the video resolution. Here, blue represents 16 kilobits, red 24 kilobits, yellow 56 kilobits, and purple 320 kilobits. In the left panel, you may notice the average video ratings seem to be different based on the video resolutions. You may also notice that these three lines on the left panel are not completely straight, and possibly wonder if the audio resolution also has an impact on the perceived video quality ratings. In contrast, the results for the perceived audio quality ratings in the right panel all appear to form straight horizontal lines, which may indicate significant influence of the audio resolution but not the video resolutions. Notice that the results for both 56 kilobits, which is on the yellow line, and 320 kilobits, which is on the purple line, appear to overlap each other. This appears to have a possible ceiling effect at 56 kilobits and higher audio resolution in terms of the perceived audio quality. The results for the perceived video quality across all subjects were analyzed using a two-way repeated measures ANOVA. The results showed a significant main effect of the video resolution and a significant interaction effect between audio and video resolutions. However, the audio resolution showed an almost significant main effect. This would suggest that there were some influence the audio resolution had on the perceived video quality. Looking back at the graph, we can see that 240p videos were perceived as better quality when they were combined with 56 kilobits than with 24 kilobits audio. The same pattern can be observed from 480p videos combined with 56 kilobit audio rather than 24 kilobit audio. A two-way repeated measure ANOVA was also used to analyze the results for the perceived audio quality across all subjects. This time, the results showed a significant effect of the audio resolution and the interaction between the audio and video resolutions. But the video resolution did not have any significant main effect. This is in agreement with the graph, as we can clearly see the significant main effect of the audio resolution, that there are 4 stable horizontal lines. The significant interaction effect reflects that the audio quality ratings are almost identical for 56 kilobits and 320 kilobits audio, regardless of the video resolutions combined, while 24 kilobits and 16 kilobits show to be rated much lower. The ratings appear to be constant regardless of the video resolutions, so this is consistent with the rating showing no influence of the video resolutions. As mentioned previously, we asked subjects to self-identify as auditorily or visually inclined. This was to help us see if there were any group effects, as most of our subjects consisted of individuals with backgrounds in audio or video production. The figure to the left represents the perceived video quality ratings from the subjects divided into 2 groups. The y-axis represents the video quality ratings, where the x-axis represents the audio resolution. Again, different video resolutions are specified in separate lines. The left graph represents the auditorily inclined subjects, whereas the right represents the visually inclined subjects. The figure to the right represents the perceived audio quality ratings from the subjects divided into two groups. The y-axis represents the audio quality ratings, and the x-axis represents the video resolution. The left graph again represents the auditorily inclined subjects, whereas the right represents the visually inclined subjects. In all graphs, the error bars indicate standard error. The figure to the left looks almost identical in both groups. Therefore, it does not appear to have a group effect in the perceived video quality ratings. 480p and 1080p especially follow very similar rating patterns between both groups. However, there does appear to be a slight difference between the ratings for 240p. Instead of the visually inclined subjects having more critical ratings of the lowest resolution video, the auditorily inclined subjects appear to have slightly lower quality ratings, especially at 24, 56, and 320 kilobits. The figure to the right appears to have a possible group effect with quality ratings for 16 kilobits and 24 kilobits. The auditorily inclined subjects appear to rate 16 kilobits and 24 kilobits significantly lower than visually inclined subjects. The ratings between 56 kilobits and 320 kilobits remain consistent between both groups, as the ratings are very similar between them. This time, we used a three-way repeated measures ANOVA to analyze the results for the perceived video quality ratings between two subject groups. The results confirm that there is no significant effect of inclination. Significant main effects were observed for the video resolution, audio resolution, and the interaction between the audio and video. No other effects were statistically significant. This confirms that there was no group effect between the auditorily and visually inclined subjects. Therefore, the perceived video quality is significantly impacted by both the audio resolution and the video resolution, as well as the interaction of the two. A three-way repeated measures ANOVA was used again to analyze the results for the perceived audio quality ratings between two subject groups. This time, it showed a strong effect of inclination approaching significance. Other components were the audio resolution shows a significant main effect. Additionally, the audio resolution shows significant interactions with two factors. The first being the interaction with the video resolution, and the second with inclination. This suggests that there was some group effect between the two subject groups. As it would appear from the figure, 16 kilobits and 24 kilobits seem to be the most different between the two graphs. Two separate t-tests were used to determine if there was significant difference between them. The results showed that both 16 kilobits and 24 kilobits were significantly different between the subject groups. This suggests that auditorily inclined subjects are more critical of lower grade audio quality than visually inclined subjects. So in summary, The audio resolution appears to have significant influence on the perceived video quality, especially at low resolutions. However, the video resolution did not seem to have significant influence on the perceived audio quality. This would suggest that while streaming a video, if the audio resolution drops, it would affect the perceived video quality. But if the video resolution drops while streaming, the perceived audio quality may not be affected. These results also suggest that there may be a possible ceiling effect at 56 kilobits audio resolution, as there was not much differentiation between the perceived audio quality ratings of 56 kilobits and 320 kilobits. An important note is that even when the results were analyzed separately between two groups, this pattern stayed consistent between the auditorily inclined group and the visually inclined group. However, on the lower audio resolutions, auditorily inclined subjects were more critical of 16 kilobits and 24 kilobits, as there was significant difference between the two groups. The auditorily inclined subjects rated the quality of both audio resolutions significantly lower than the visually inclined subjects. It is interesting to notice that the visually inclined subjects did not show the same pattern in the perceived video quality, and the auditorily inclined subjects appeared to be even more critical of 240p video resolution than the visually inclined subjects. As there appears to be a possible ceiling effect at 56 kilobits, this could help form a practical recommendation for the streaming industry in limited bandwidth. First, it is recommended to maintain at least 56 kilobit audio. This is important as the results suggest the audio resolution also influences the perceived video quality. And if there is room left in the bandwidth after at least 56 kilobits of audio is maintained, the video resolution should be improved. There are some limitations in our study. First, the subject size is limited. While we were fortunate to obtain 42 participants to complete the study, this is a relatively small number of subjects. It is also important to mention the subjects were using a variety of equipment. There was no control over the screen they were viewing on or the audio equipment they were listening through. This was inevitable in an online experiment, as the study was designed in the middle of the pandemic in 2020 through 2021. Because of the limitations of COVID-related research protocol, an online experiment was the best way to perform this study. While this made it impossible to control the experimental environment for every subject, in a sense, it made the experiment environment very similar to the streaming practices in real life. It made our findings relevant to the streaming industry through the subjects using their own equipment that they would be most likely to stream media on. Looking at future directions, we are hoping to take this experiment into the in-person theater direction. We would like to mostly repeat this experimental design in a controlled theater with controlled audio and a 4K projector. This would let us include 4K stimuli, which would make it possible to test more diverse stimuli, including top quality videos. We will re-examine the group difference based on auditorily or visually inclined subjects. Most importantly, we would like to compare the findings of this future study with the current one to see how different subjects perceive the quality in a controlled theater versus their own equipment they would stream media on. Thank you for all your attention, and please feel free to contact me at any time for any further questions or comments.